They make the world go round. Wow. And first thing to remember is that percents mean what, Lacey Robbins? Per cents. Cents is, yeah, well, kind of. Centurion, a century, a centipede, a centigrade, a centa, Olivia?
Out of 100?
Yeah, it means out of 100. And even our little percent symbol, if you think about it, why can't I draw a perfect circle? You know, somebody apparently, when they did the percent thing, was just thinking, hey, this means out of 100, so they just rearrange the thing and kind of flip it around. Whoa! It's kind of amazing. Almost like Matthew's chapter throwing for whatever. Now, simply, here are some things you're going to need to do. You're going to need to be able to change fractions to percents. And you need to change decimals to percents. And there are, ladies and gentlemen, lots of different ways you can go about doing this, but the one surefire way of changing anything to a percent is to multiply whatever by 100%. If you multiply something by 100%, you will change it into a percent. For example, if I have 3/4, like I said, there are other ways, and maybe even quicker ways to do this, but this is always the surefire way. If I want to change that to a percent, I multiply it by 100%. It ends up being, when you multiply across 300 over 4%, and 4 goes into 375 times, so it's 75%. Now, granted, Aiden's saying, man, that's kind of long and awkward, when you could have just, another way to do it, if it works, is this. Just change the fraction so that it is over 100. 3/4 equals what number over 100? Well, you multiply by 25, you multiply by 25, and you get 75 over 100, which is 75%. And that's all well and good, but sometimes there's fractions that doesn't work nicely for. For example, let's go to a stunning color here. For example, 7/8. If you tried to do that with 7/8, you'd have to say, well, 8 times what number gives me 100? It don't work out too terribly good. So when that happens, then you go back to the surefire method, which is this way. If I take 7/8, multiply it by 100%, I end up with 700, over 8, which means I have to divide 8 into 700, and 8 goes in 700 what? 8 is 64. You get a goofy fraction. 87, 56, 87 and 1/2%. Okay, so by all means, if this works for you, feel free to do it. But there are going to come times when fractions don't convert into nice percents, and this is the easy way to do it. Decimals are kind of the same thing. You know, if you have 1.5 and you're supposed to make that a percent, you just multiply it by 100%. And the nice thing with decimals is when you multiply by 100, you just need to do what, Riv? 2 places. All I'm going to do is move this 2 places, and it is 150%. Or if I said 6 is what percent? 6, the number 6 is what percent? You just say, well, Kendall, 6 is what percent? 6 times 100 is 600%. Shazam. Do you have that down? Am I doing something wrong? Now, you must say there's got to be more than that. Gotta be more than that. Percent story problems. Ooh. Still under the same thing. Just put story problems under it. Write down this, for example. 40% of the 30 students rode the bus. 40% of 30 students rode the bus. 40% of 30 students. How many students rode the bus? How many rode the bus? When you come across a story problem, this one's kind of an easy one, and you can probably maybe give me the answer right off the bat. What I very much need to see is you to draw a percent. Why this is not writing, I don't know. Percent slash ratio box. Because a percent is nothing more than a ratio. You know, it's something, you're comparing something to 100. You know, you get 5 wrong on a math quiz out of 10 problems. What percent is that? Well, 5 out of 10 is what number out of 100? It's a ratio. And your ratio box will always look like this. It will always be split into 6 little squares there, where your percent is this first column going down. The actual is the second one. And then these things are what you are comparing. For example, I'm talking about students who rode the bus. Well, if I have students that rode the bus, I must also have students that didn't ride the bus. And percents will always add up to the total. You must be able to get a total to find percents. And the nice thing is, one of those you know automatically right off the bat without even looking at the problem. You always know that your total percent is 100. 100% is everything, is all. So that always goes in this box, no matter what. The rest of these will change. And in this one, I know that 30 students rode the bus, or 40% of the 30 students rode the bus. What does 30, where does 30 go? Is that how many rode the bus, how many did not ride the bus, or how many total students there were? Total students, so it goes here. And then they'll always give you one of these 4 things. 40%, was that how percent that rode or percent that did not ride? Rode. Look at Brady's all over that. And if I know these 2 numbers have to add up to 100%, this one has to be 60. So you'll always be able to figure that out. Now, what am I looking for? How many rode the bus? The actual number of bus riders, that is this box right here. That is that box right there. Since you don't need to know this box, you can ignore this part of the problem because we're not looking for that. And then you just look at these as being equal ratios. Or think about this as being a fraction. 40 over 100. 40 over 100 will equal what number over 12? What number over 30? Sam, how am I going to do this problem? How do I make equal fractions there? Can I go from 100 to 30? Not as it is, but look at this fraction. Can I reduce that fraction? What can I reduce it by? 10 right off the bat. You can cut off the ending zeros. Now can I go from 10 to 30? By multiplying by 3. And then 4 times 3 is 12. And 12 would be how many students? What get you there? Have we done that before? Mm-hmm. Let's do another one just because. 3 of 5 basketball players scored more than 10 points. You guys are basketball people. 3 of the 5 B-ballers, must be the other class we're talking about, scored, what, 10 points? 10 points. What percent scored more than 10 points? So this is your standard run-of-the-mill percent story problem. This is my percent. This is my actual. What am I comparing? People that scored 10 points, right? To people who did not score 10 points. Hello. Did not score. How does that even happen? And this is your total. Somebody want to fill in the blanks for me. Somebody give me one thing I know there. One thing I know there is, Brendan Massey?
The total percent is 100%.
Always. Well done. What else? Another one I know. Brady?
There's 5 basketball players.
There are 5 total basketball players. Wow, look at that. What else do I know? Aiden?
3 basketball players did score.
3 of them did score 10 points. Based on that, I can figure out what? 2 of them didn't. Where does the 10 points go? Rev? Thank you. 10 points is just a label, has nothing to do really with figuring out the problem. They could have had red hair. 3 of the 5 people had red hair. You don't need to know. Which one am I looking at? I am looking to solve what? What percent made more than 10 points? This percentage right here. So it is what number over 100 is the same as 3 over 5. You don't need this middle piece here. And that one you can do because you can go from 5 to 100 by multiplying by 20. 3 times 20 is 60%. 60%. Do you think that'll get you home? Or the last part the book asks you is this: a quart is what percent of a gallon? A quart is what percent of a gallon? Now this one, ladies and gentlemen, really isn't necessarily a story problem. They're just asking you to change a fraction into a percent. Because you can always interchange percents with fractions and then change the fraction to a percent. A quart is what fraction of a gallon? How many quarts are in a gallon?
4.
There are 4 quarts in a gallon. So 1 quart is what part of a whole gallon? 4 quarts make up a whole gallon. You have 1 of them, so 1/4 is what number over 100? 25. So it's 25%. I don't know if that makes any sense. Uh-oh. To you or me.